This video is about finding the zeros of a polynomial. You will see people using P over Q to find the zeros of a polynomial, and you get a lot of plus or minus 1 and plus or minus 3 and stuff. I'm not going to do any of that. Instead of doing any of that stuff, I'm going to begin with a graph. I graph this polynomial in Desmos. Let's begin by taking some zeros that we can find from the graph. One zero is at -1, another zero is at 1. That's useful if we got zeros already. So what I'm going to do is, I know one zero is at +1 and one's at -1. Because it's to the 4th degree, I know it's actually 4 zeros. So notice in zeros there, they're not real because they're not existing on the graph. So for that reason, I got to find them. So to do that, I would take the polynomial that we have and use symbolic division with it. So we take that polynomial, use the coefficients 1, 1, 5, -1, and -6. And then use symbolic division to simplify that to be a smaller polynomial. This becomes 1. 1 times 1 is 1. Add that up is 2. 1 times 2 is 2. Add those, you get 7. And multiply this together, you get 7. Add those, you get 6. 1 times 6 is 6. Remainder 0. So this new polynomial is a polynomial 1x to the third plus 2x to the second plus 7x plus 6. And if you remember symbolic division, the reason why it's x to the third is because you drop down one exponent to make x to the 4th. Since I got a second zero, -1, I can do symbolic division again with my new answer. So I'm going to take my new answer and then use symbolic division a second time. So from there, the coefficients are 1, 2, 7, and 6. And bring the 1 down and get 1. So -1 times 1 is -1. You add those, you get 1. Multiply those together, and it's -1. Add those in the 6. Multiply those together, you get -6. Remainder 0 again. So now it's going to be 1x to the second plus 1x plus 6. So what I know is I had two zeros. My zeros were 1 and -1. Those are two that we knew of. So I can take my polynomial that I have and treat it as a factor. Exactly what it is. So if I want to know when this function is 0, I know one factor is x subtract 1. The second factor is x plus 1. The final factor is 1x to the second plus 1x plus 6. You want to know when that's 0. So I'm change this y to become 0. We know what makes these 0. Here they are here. We need to know what makes this one 0. And the best way of finding out is quadratic formula. So I'm going to take that equation, I'm going to solve it with quadratic formula. So quadratic formula is -b plus or minus the square root of b to the second subtract 4ac all over twice a. Again, this is a. And essentially what you want to do is you want to plug in a, b, and c from this equation, this expression, into the quadratic formula to figure out what makes that part 0. All right, so I'm going to put it here. The equation was 1x squared plus 1x plus 6. You want to know what makes equal to 0. So a is 1, b is 1, c is 6. So the formula says it should be -1 plus or minus the square root of 1 to the second subtract 4 times 1 times 6 all over 2 times 1. So that gives you -1 plus or minus the square root of 1 subtract 24 is -23 all over 2. So you can't square root negative, so that's imaginary. So it's -1 plus or minus I square root of 23 all over 2. So this is my imaginary set of zeros. So those are two more zeros here because you got a plus and minus sign. So the zeros of that polynomial are 1, -1, and -1 plus the square root of 23 over 2, well, I square root of 23. And -1 subtract I square root of 23 all over 2. Remember we said you had to have 4 zeros, and now it has 4 zeros. And that's how you define the zeros of a polynomial. So as a recap, we graphed it to find some of the zeros, and then we use those zeros we found and use synthetic division to reduce that polynomial to be a smaller polynomial that we use a quadratic formula for. That's all I have. Good luck.